Everyone to Chapter 11, Lesson 2 on triangles. We've been learning about polygons. There's going to be a Pear Deck link here with the video kind of embedded in it, so this will go away. But this goes with Lesson 11.2 in your Go Math and homework pages 647, 1 through 6, and number 6, and then you can need to do page 648 all. As you come to the pair, go ahead and stop the video, work out the problem, and then when you're done, turn the video on and see the answer. All right, so let's take a look. At the end of this lesson, you'll be able to classify triangles into categories. So this is what we're doing a little bit higher level. You've been looking at triangles before, and now we're classifying them, comparing and contrasting the features that they have into isosceles, scalene, or equilateral triangles. And we're also going to take a look at the angles with inside the triangles to see if it's an acute triangle, an obtuse triangle, or a right triangle. So I want you to write, using your Pear Deck, how can you identify and classify triangles? What do you know about recognizing a triangle, or maybe classifying them, sorting them by their features? Go ahead and pause the video and put in your answer. All right, hopefully you turned it on and entered your answer. So we're studying, here's our vocabulary. For Unit 6, we have our polyhedron. Polydro, a solid figure with faces that are polygons. So here's your solid figure, and your polygon is a closed system. It is a closed system that has 3 or more sides that connect all together. Okay, so this polyhedron is when you attach all of these polygons together and you create a solid figure. They don't always have to be squares and rectangles. They can be triangles and pentagons, like we learned in the other one, and hexagons. A prism, prisma, a solid figure that has 2 congruent, which means equal, polygon-shaped bases and other faces that are all rectangular. So congruent means equivalent or equal. There we go. Just a different word for that. So this right here is a prism, and so is this one as well. But if you take a look, a prism has to have the bases that are all rectangles. So this rectangular prism right here isn't. So well, I guess that wouldn't be a rectangular prism. All right, moving on. Pyramid. A solid figure with a polygon base and all other faces or triangles that meet at a common vertex. So here's your polygon base, which is a square, and then you have your triangles that kind of pop up into the one vertex. Remember, vertices are those points, common vertex. Quadrilateral has that root word quad for 4. A polygon with 4 sides and 4 angles. Rectangular polygon, a polygon in which all sides are congruent, equal, and all the angles are also congruent. All right, so we're going to take a look at that. A scalene triangle, a triangle with no congruent sides. That means none of them are equal. A unit cube, that's a cube that has a length, width, and height of 1 unit. So that 1 unit can just be the symbolic 1 unit, kind of like in algebra, or it can actually be 1 meter, where the height, the width, the length, they're all 1 meter or 1 centimeter or 1 inch or 1 foot or 1 yard. So when you have a unit cube, every aspect of that has a measurement, a length of 1 unit. Volume is the measure of a space that a solid figure occupies, which is a little bit different than capacity. So capacity is what goes inside the object, where volume is the measure of the space that a solid figure occupies. All right, we'll be learning about those as we go along. All right, so remember when we solve our problems, we search for clues, we take a selfie, we estimate our answers, we line up the numbers, we figure out the answer and solution, which is your F. For I, you include all your work, and E stands for explain to writing, how you know your answer is reasonable. All right, so let's take a look at this Epcot Center Spaceship Earth building in Orlando, Florida. You may see patterns of triangles. The triangles outlined in the pattern to the right have 3 congruent or equal sides and 3 acute angles. So what type of triangle is outlined? So we're going to complete the sentences about all these different types, and we'll come back to this. All right, so how do we know the different kinds of angles? So here we go. We have equilateral, isosceles, scalene, right, acute, and obtuse. And one of the things I want you to notice is the way they're presented is in an equilateral triangle. all the sides are equal. And you see how they have these arcs, and there's only one arc for each one? That one arc means that they're all the same size. This right here, this square, represents a right triangle. And if you take a look, it's showing the measurement of these angles, and they are not all the same size because a right triangle has a measurement of 90. This one here has a measurement of 60 degrees, and this one has 30. Here you have another triangle with 3. Now you notice it isn't showing you any angle width, but it does show you the length of all the sides. And this side is 3 inches, 2 inches, and 3 inches. And here's a scaling. Again, it's not showing you the angles with a side of 5 inches, 3 inches, and 4 inches. So when it's an equilateral triangle, all the sides have to be the same length. So every single one of these, regardless if it's 3 inches, they all need to be 3 inches, 4 inches, all 4 inches. For an isosceles, only 2 of the sides need to be the same length. So here we have this side is 3 inches as well as the right side is 3 inches, but this base right here is only 2. So all 3 sides are not the same in an isosceles, 2 of them are. For an equilateral, it has the root word equal. All 3 need to be the same size. All right, in a scaling triangle, it's sort of different. It's when all 3 sides are completely different length. All right? So it does not have congruent. Congruent, remember, means equal. All right, classified by the measure of their angles. So we're going to do this. I'm going to stop the video, and I want you to just kind of study these shapes of angles. This should be a review from 4th grade. And how do you know your angles? All right, so this symbol right here, my dry symbol. All right, so here you have a line and another line intersecting, coming together, and this is your vertex, right? That's that point. So when you show a square as a symbol for how these 2 lines are meeting, that's called a right angle. And right angles are 90 degrees, and they're very special because these 2 sides sort of come together perfectly, forming a right angle that are 90 degrees, and we use it for shelves, we use it for all sorts of things. So what happens is when a triangle kind of comes out and goes through, this is now called a right triangle because it has a right angle. Now, something you may not know, but just like a triangle has 3 sides, a triangle has obviously 3 angles. Okay, 1 angle, 2 angle, 3 angle. And these angles, angle A, angle B, and angle C, 1A, B, and C, all equal 180 every single time. Isn't that interesting? So they will always add up to 180 degrees. So in this case, this is 90 degrees, which leaves this angle and this angle to sort of come together and make 90 degrees somehow. So it could be 45, 45, it could be 30, 60, but every triangle, the angles inside of it add up to 180. So when you see that square, that's a right angle, and that's something you're going to need to memorize. But what about those cute little angles? All right, so and that is going to be less than, we'll make that A is less than 90, B, and C. So let's say this one was 30 degrees. This one was 60 degrees. Oh, that can't be true because it has to add up to 180, right? So let's say this one's 50 degrees. This one is 60 degrees. That's 110. And this one is 70 degrees. So I know it's not to scale. But all of these angles, angle A, angle B, and angle C, they're all less than 90 degrees. All right? So it's not a right triangle. There's no squares represented in this one, and you can tell that way. Now, when you add them up together, the measurement of angle A, B, and C, what do they equal? They should equal 180, and that's something you just need to know. You need to know that anytime you add up the inside, it's equal to 180. All right, now in this case, since all of these angles are smaller than 90, since all the angles are smaller than 90 degrees, they're acute, right? They're called acute angles. So this is an acute triangle. because all the angles in an acute triangle, and the key word there is all, are less than 90 degrees. But what happens if you have a really big angle? So here's a really big angle, and if I was to put that 90-degree square in there, you would see it's bigger than that 90 degrees. So this angle is larger than 90 degrees. All right, and we're going to say for this case it's 120. So then if I connect these, this will be A, angle B, angle C at the vertices A, B, C, which are the points. Okay, that means that 120 plus C and B, these two vertices, has to equal 180. Well, you can kind of make up some numbers here. Let's say C was just 20. That would be 120 plus 20 is 140, so B would have to be 40. Again, all three angles have to be add up to 180 degrees. But this huge angle that is more than 90 degrees, this 120, which is greater than 90 degrees, is called obtuse. And it's coming from the root word ob, which we get out of obese, which means it's large. It's a large angle. And because there is one of these, just one inside this triangle, this becomes an obtuse triangle. So an obtuse triangle has one large angle greater than 90. An acute, a little cute triangle has three, 1, 2, 3, that are all less than 90. And a right triangle, you'll see the square, they meet perpendicular, will have one angle that has a right, one angle has a right angle. And why can't we have a triangle with two right angles? Well, I'll give you an example. All right, a triangle only has 3 sides, and there's no way to connect them. They'll turn into a square, but that has 4 sides. So there's only going to be one angle that'll be 90 and a right angle. There'll only be one angle that'll be greater than 120 and obtuse angle for the sides to connect. All right, so now that we've done this, let's take a look at your problems. So in equilateral triangle, all 3 sides are all exactly the same length. An isosceles, 2 of the sides have the same length, 1 does not. A scalene, none of them are the same length. A right has one 90-degree angle, you see it right there with the square, and acute has 3 tiny little angles that are all less than, what is it? 90. And an obtuse angle has one big angle that is greater than 90. All right, so the type of triangle outlined in the pattern can be classified by the length of its size. Right here would be an, what is it? All 3 look at the same, so that would be an isosceles, or excuse me, an equilateral triangle, because they're all 3 the same. The triangle can also be classified by the measure of its angles. So again, these are all 3 the same size, and they're all kind of cute and small, so that would make them an acute triangle. So a triangle can be equilateral and also acute, and that's what you see when you look at the Disney Epcot. All right, so let's get moving along. So we're going to classify the isosceles, scalene, or equilateral, then write acute, obtuse, or right. So take a look, and you can go back and forth between these 2 informational sheets. So hopefully you filled this in when you did your pear deck. All right, so pause the video, go ahead and fill it in, and let's see how you do. Right away, side 1, side 2, side 3, 8, 6, 10, none of them are the same, so that makes them scalene. This one is a really cute angle, it's 53. This one is 37, and this one has a square, which makes it a right angle. So this triangle is also a right triangle. So let's take a look at this one. Now, do you see these hashes? That is a visual representation telling you, the reader, that these sides are the same length. The same thing as these angles. Okay, do you see how these have one kind of arc? That's a visual clue that these angles are also the same length. Now, it's giving you the measurement of this big angle because it's greater than 90. So that's telling me it's an obtuse, a very large angle, which means I already know this is an obtuse triangle. However, because the 2 sides are equivalent, are congruent, equal, I also know it's an isosceles because that was what we filled in here. An isosceles has 2 sides that are the same length. All right, let's take a look at this one. Go ahead and pause the video and work it out. All right, hopefully you did it. So here we have a triangle that has two sides that are the same length and the other one isn't. Remember what that is? It is an isosceles, two congruent sides. All right, so that was kind of easy. And is it a scalene, or excuse me, does it have just acute, obtuse, or right angles? Well, there's no right angles because see, there's the right angle symbol. And you know what? I can tell these are not greater than the square, so I know this is all acute. So let's take a look at this real quick. All right, so here was your triangle. And a really good clue is you see how you have your squares here? And you see how that doesn't fit, so that's not a right triangle, right? And that's not a right triangle. It would have to come down here. And obviously you can tell that's not. So this one, all of these angles, here's a right angle. All of the measurement of these angles is less than 90. So these are all really cute angles. So this is an acute triangle that we had. All right, now let's take a look at the sides. Oh yeah, we already knew it was isosceles. Okay, this one, 7-inch, 25-inch, and 24, so I know it's scalene, right? Scalene is when none of the sides are the same length. But let's take a look at the measurement of the angles. See that clue? That's a right triangle. I know it immediately. All right, so here's one. We're just using words now. So this one has sides that are 44 millimeters, 28, and 24. Well, automatically, are those the same length? Nope. So what is it? It's a scalene triangle. Scalene triangle has no congruent sides. All right, but these angles, 110, 90, excuse me, 40, and 30, well, that 110 is greater than 90, isn't it? That's a very large angle. So this is also an obtuse triangle. Again, let's take a look at the sides, 23, 20, 13. None of them are the same. I know it's scalene. Angles, 62 less than 90, 72 less than 90, 46 less than 90, but none of them are 90, so it's not a right angle. None of them are greater than 90, so it's not obtuse. So this is a little acute angle. And I had that in this right here. All right, so Mary says her pen for a horse is an acute right triangle. Is this possible? So let's take a look. Pause the video and work these three out, and then turn it back on, and we'll look at them ourselves. All right, hopefully you paused the video. She said the pen for her horse is acute right triangle. Is that possible? All right, so first what she's saying is we have a right triangle for her horse. It's a bigger pen than this. This is just a example. Well, to be a right triangle, you have to have a right angle. Do we have a right angle? Absolutely. Check off. But to be a little cute angle, every angle or triangle, every angle in the triangle has to be less than 90 degrees. Okay, it has to be less than, well, this one is 90 degrees. Okay, that is 90 degrees. So it's not less than 90 degrees. So this is not an acute triangle. So what's your solution statement? The pen is not an acute triangle. All right, make sure that you start writing those solution statements. What's the other problem you had? Next, Karen says that every equilateral triangle is acute. Is that true? Well, actually it is true. Let me show you why. It's kind of interesting. Remember that every triangle has three angles, right? And these angles, A, B, and C, that come out of these vertices, these points, A, B, and C, they equal 180 degrees. Well, when you have these sides that are all the same length and this measurement that is all the same length, you are taking 180 and you are dividing it into three equal parts, right? 180 divided into three equal parts. Well, what number times 3 is 180? Or what is 180 broken up into three groups? Can you tell? Well, 3 will not go into 1. So I'm going to go to the 18. 3 will go into 18 6 times. 6 times 3 is 18. 18 take away 18 is 0. I still have to account for this 1's place value. So how many 3's going to take out of nothing? 0. So if I take 180 and I break it up into three groups, I have 60 in each group. So this is why any equivalent triangle is an acute triangle as well, because all of these measurements are less than 90 degrees. All right, so remember, every triangle, if you add up all the angles, measure 100. So it says draw 3 triangles, 1 equivalent or equilateral, 1 isosceles, and 1 scaling. Draw and label and explain. So I'd love to see these. Okay, so take the time, and if you need to go back here to look at your cheat sheet of what they are, absolutely go for it. All right. All right. Go ahead, pause the video, get this done. All right, if 2 of the triangle angles measure 42 degrees and 48 degrees, how would you classify it as acute triangle, obtuse, or a right triangle? Well, this is where you have a multi-step problem, right? So let's take a look. So here are your 2 angles that you know. So you're going to draw a triangle. We'll say A, B, and C are those pointed vertices. So this becomes angle A, angle B, and angle C as well. All right, well, this one's 42 and this one's 48. Well, I know that I need to add all of these 3 angles together, and they're going to equal 180 degrees. So I have to know that. I have to know that the 3 sides, no matter what, in any triangle, the 3 angles equal 180. Well, so what operation am I going to do? I have 180 all together. I have 1 angle that's 42. I have 1 angle that's 48, and I don't know this one. So this is where that bar model is really nice. So what can you tell? You probably could already figure out you need to add these 2 together, which gives you 4 plus 4, 8, 90 degrees. These are 90. And what number plus 90 will give you 180? Well, 180 minus 90 is another 90. So guess what? This, even though I didn't draw it well, is actually a 90-degree angle, which is a right angle. So this is a right angle. It's not obtuse. There's no angles that are larger than 90. One is 90. It's not acute because all the angles would have to be less than 90. They couldn't be 90, but it is a right angle triangle because it has 1 right angle. All right, that was kind of tricky. All right, what is the classification of the following triangle? Now you're looking at the sides because you're using words like scalene, isosceles, or right. Okay, well that's kind of weird. Normally it's scalene, isosceles, or equilateral. All right, so what is the classification? Well, first of all, there's no right? You can't see it. There's no right angle. There's no square. So is it a scalene? Are all the sides different lengths? Or is it isosceles where 2 of the sides are the same length? Well, that's easy. Look, 4 centimeters, 7 centimeters, and 9 centimeters. So those lengths are not the same, so I know that it is scalene. Why is it not a right angle? Okay, real quick, let's take a look. Well, this measurement is 107. So if this again was A, B, and C, this would be angle C, and A plus B plus C would be equal to what? 180. So if C is 107, what would be A and B? Well, again, let's go to our bar model. I have 180, and I'm going to use up 107. So what operation to find the difference? Be subtraction, 180 minus 107. Can't take away 7 from nothing, borrow from the 8. 10 take away 7 is 3, 7, and 1 take 1. So this is worth 73. So if I cut this in half somewhere or in the middle, or if I do 7 or 3 plus 70, I could do 33 plus 40. No matter what the combination is going to be, none of these will ever be, angle A or angle B will never be 90 degrees. And remember, to be a right triangle, it has to be 90 degrees. So you had to know that all 3 angles equal 180. You had to know to subtract the angle measurement that you had to find out what, if you added these 2 angles together, it could be, and it came out to 73, so you automatically knew it would never be a right one. All right, try 3 and 4. Go ahead and pause the video. These are going to be going back to conversions. It's a good spiral review. All right, hopefully you stopped the video because you had the pair and you worked these out. How many tons are equal to 40,000 pounds? And then you had another one which was choose a symbol to make the following statement true. You were comparing 6 kilometers to 600 centimeters. All right, so let's work that out together. All right, so first I'm going to do my conversion. And what I need to know and have memorized is 1 ton, which they use a capital T, which always throws me. 1 ton is equal to how many pounds? Do you remember that? It's equal to 2,000 pounds. All right, so what measurement do I have? I have, well, first of all, to go from 2,000, the larger to the smaller, I have to divide by 2,000 or multiply by 1 over 2,000, right? They're the same thing. If I divide by 2,000, that's the same as multiplying by the inverted one. All right, but if I'm going from 1 ton to 2,000 pounds, if I'm converting from tons to pounds, I'm multiplying by 2,000. So do that conversion chart. Now ask yourself, what measurement do I have? I have 40,000 pounds. So I'm going to take that 40,000 and I'm going to divide it. Remember, your fractions are division by 2,000. Okay, so this is easy. Properties of 10, just take away those zeros. What do I have left? I have 40 halves. Well, what's 40 halves? You're going to see that right away, right? 20. So 40,000 pounds is equal to 20 tons, all right? So you could have done this 40,000 divided by 2,000. I mean, there was a lot of different ways, but just remember that your fractions are division. Your dividend, what normally goes inside, goes on top, and your divisor, what's breaking it up, goes on the bottom. It's your denominator. All right, your other one was kilometers to centimeters. And this isn't as easy as it looks because there's a lot of steps to this conversion. So what do I know? I know that 100 centimeters is equal to 1 meter. And I know that 1,000 meters, now look at how I'm doing this, is equal to 1 kilometer. So if 1 kilometer is 1,000 meters and 1 meter is 100 centimeters, then what would be 1,000 meters in centimeters? Well, again, let's take a look. If we're going from meters to centimeters, I said 1 meter is 100. So to go this way from centimeters to meters, I'm dividing by 100, all right, or multiplying by 1 over 100. If I'm going from meters to centimeters, I've got to multiply by 100 to get there. Well, again, I have 1,000 meters. So I have to multiply that by what? Well, actually, I don't have 1,000 meters. I have 6 kilometers, which would give me 6,000 meters. Do you see that? That was a 6 kilometer I am comparing. So I have 6,000 meters. So I have to multiply that by 100. Well, again, the properties of 10, I just literally add those two zeros and the ones I already had. So 1, 2, 3 for my period. So I have 600,000 centimeters. So this equals 600,000 centimeters. So which one was bigger? Obviously the 600,000 centimeters, which is the same as 6 kilometers. So there's your answer for that problem. All right, well done. So how can you identify and classify triangles? Remember, you're looking at their sides and which of these sides are the same length. If all three are the same length, they are equilateral. If just two of them are the same length, they are isosceles. And if none of them are the same length, they are a scalene. And I can always remember these because of the S. You can also classify them by the angles. If one angle has a 90-degree right angle, it's a right triangle. If all of them are acute and less than 90, it's called an acute triangle. And if there's one really big, larger than 90 degrees, 91, 92, 105, it is an obtuse triangle. So that's how you classify them. All right, so really quickly with your pear deck, how do you feel about classifying triangles? Well done today, and I'll see you in class.